Hello, kids. Hello, good evening. Hello, kids. Good evening. Good evening. Aisha, hello. Good evening. Sai, hello. Good evening. Good evening. Start your video, kids. Start your video. Start your video. All right. So, welcome, kids. Welcome to 90 Plus Double Power Tuition, the world's first learning assurance model tuition. Welcome to the class. How are you all? How are you doing, Aisha? How are you doing?
I'm good.
Doing good. Sai, hello. Good evening, Sai. Are you there? Start your video.
Yes, Miss, I'm there.
Yes. Hello, Sai. Are you here? Good, good. How are you feeling, Sai? Are you feeling better?
Yes, Miss.
Yeah or no?
Yes.
Yes. Are you sure?
Yeah.
100%? Not 100%. Why? Still, you know well today also? Hello, Sai. Can you speak a little louder, clearer? Because I can't hear you. Hello, hello. I'm audible perfectly, right?
Yes, Miss.
I see. I get it. I get it. That's right. Okay. Stay focused on the class. Okay. So, kids, once again, welcome to the class, and I hope you know the highlights of our PCM model tuition. Here, you can choose the chapters that is ongoing in your school, which is all live at the moment. And also, in this new double power model tuition, you can here we have learning assurance classes. That is, after each day, we have workout sessions through which we make sure that you guys don't just watch and go, but also study. And our main aim is to improve your scores, and together we can do it. Okay? And through these classes, you guys have to make sure that all your doubts have been cleared, everything is perfectly clear, the chapters, the concepts, everything. Okay? And together we can ace it. You can get 100%. Isn't that what you want? Okay. So let's go, shall we? Ready, kids? Ready? Ready, set, go. Let's go, let's go, let's go. Okay, so buckle up because it's gonna be a fun ride. Okay, on your mark, get set, go. Day one workout session. So guys, are you prepared? Are you guys prepared for the session? As I've told in the last class, because you guys will do each and every question that you get on this session. Okay, I'll share a question on screen. You will have like a minute or more depending on the length of the answer, and both of you will have to answer it, solve it, and I'll call any one of you randomly to solve that question on screen. Explain it, and I'll follow your lead. That's how it's gonna be. Okay? So for that, you need a good knowledge of what we have learned on day one session. You should know how to dwell or tinker with all the theorems that we studied on day one session. Okay? We have to use those theorems as application in order to solve problems. So you have to use your brain there. See? That's how the exam questions are gonna be. It will make you guys use your brain, of course. That's how we get scores. So you need good amount of practice. So let's go. So before we start, I want you guys to sum up all the things that we've studied to now. Okay, Yoshita said that is Sai. Aisha, come on kids, tell me what are we doing? What are we studying? What did we study? Tell me about it.
Miss, we studied what a circle is.
Yes, we've studied what a circle is. We
What is
studied about
circle?
some yes. What did we study about a circle?
Um, that it has a fixed point called the radius, the center of the circle, and then it also has a fixed distance called radius, and the longest part is the diameter.
Longest chord is the diameter. Good.
And then we learned about the
Then we studied a lot of theorems, right? Did you study all the proofs?
yeah,
Can you write it without looking right now?
yeah.
Because I'll make you guys write any proof randomly. In your exam, all the proofs are important. Any proof might be asked and you will be asked to prove it. Prove it. And you might be asked to prove it through applications. So like, you will be asked questions and to use that theorem also. Why Aisha? Why didn't you study?
I studied, but you know the like proof, the first part where I supposed to explain it. That part I didn't like learn by heart. I studied only the
Prove.
things in
Okay, given and to prove, right? Pretty easy. Just read the question. Whatever is given in the theorem, right, that is given. Okay, whatever we have to prove, right, that has to prove. Okay, you have to study to prove, and like after completing all the questions in our workout session, I'll make you guys write any like we have studied a lot of theorems, any two of them. Okay, randomly. So every workout session is that's how it's going to be. So you have to come prepared, whatever we have learned. And in case if you're not able to, you'll get in both sessions. Okay, this is a very fun and happy, chilling class, but you need to study also, right? That's our main aim. Okay, that's what we are here for. Okay, let's do this. Yeah, let's do this, guys. Okay, here's a very easy question. We'll start with the easy, simple questions. So the radius of a circle is 8 centimeter and the length of one of its chord is 12 centimeter. Find the distance of the chord from the center. So read the question. Tell me which theorem we can use here and find the answer. The radius of a circle is 8 centimeter. Draw the circle, draw the figure, always draw the figure. And the length of one of its chord is 12 centimeter. Find the distance of the chord from the center of the circle. Aisha, your video is turned off. Start your video, Aisha. Start your video. Your video. Okay, okay, fine, fine. No, so kids, you have six, not 60, maybe 40 seconds. Easy, right? So kids, which theorem are we using here? What's the theorem that we can use here?
theorem.
Yes, good. So come on, tell me.
10 square, 10 centimeter.
Okay, let's see. You can write your answers in the chat box, okay? Give your answers in the chat box. The theorem that we use is perpendicular from the center to a chord. Yes, Yoshita, your voice is not at all coming here. Type your answer in the chat box, okay? Okay. So we have two answers. Let's see who did it correctly. Okay. So let's start with Aisha. Okay, explain what do we do?
So basically, I use the Pythagoras theorem. A square
Oh,
plus b square equals to c square. So 8
good.
square, and the chord has to be bisected into two, so it's gonna be 6 centimeter.
Very
So
good. See, what's the theorem? What's the theorem? You have to write the theorem over there.
I'm not sure.
Perpendicular from the center, a perpendicular line from the center to a chord, bisect this chord. Perpendicular line from the center to the chord, bisect the chord. You have to write that. That's why you need to learn the theorems. Got it? Otherwise, you won't get the full point. You have to write it, right? Perpendicular from the center to the chord, bisect the chord. So we know that
Yeah,
AB is, yeah, we know that AB is 12 centimeter, isn't it? So AC is equal to 12 by 2, which is equal to 6 centimeter. Okay, very good, very good. Now, we're using Pythagoras theorem. We know that hypotenuse square is equal to base square plus height square, isn't it? So hypotenuse is the side opposite to angle 90 degree, that is 8 square. So 8 square is equal to, come on, continue, Aisha.
8 square equals to 6 square plus c square.
8 square, okay.
And then 64, I did plus 36 equals to c square. So 100 equals to c square. So the root of 100 is 10 centimeter.
Okay. So let's take 6 to the other side, right? Listen, constants on one side, variable on the other side. Okay, so we don't know square. Let's take 60 side. So 8 square minus 6 square is equal to 8 square. So what is that 8 square? You did plus there. That's the mistake. Should we plus it? Is it what we have to do? When we take one number to the other side, if it's positive, it becomes, if it's added, it becomes subtracted, right? See, 6 square is added to x square. So when we take it to the other side, it becomes minus. Okay, that's why you made a mistake. Okay, so 64 minus 36 is equal to, come on. Come on, continue, continue. Okay, Sai, are you back? Okay, Aisha, continue. Your
One
Sai?
second.
Okay, Sai, what mistake did you make here? You got 5, right, as the answer?
I got 28 root.
Root 28, yes, that's correct, that's correct. Okay, but in the chat box, I thought he said 5 centimeter, that's right.
Just I tried finding the root of this.
Okay, okay. Okay, so which is 64 minus 36 is equal to? Oh. 64 minus 36 is equal to?
38.
28. Aisha.
No, I meant 28, sorry.
28. 28 is equal to h square. So h is equal to? Is equal to? Root 28. Okay. So h is equal to root 28. So what do we have to find? We have to find the distance of the chord from the center. So h is what we need to find. So let's see. Let's see if we can take anything outside the root, shall we? We have to see if there is anything that we can take outside the root. So try and factorize 28. Try and factorize 28. 28 is equal to 4 into 7, right? 4 is equal to 2 into 2 into 7. So 28 is 2 into 2 into 7. 2, there is a pair of 2, so we can take it outside. So 2 root 7. If there is any pairs inside the root, we can take it outside, right? That number. So the distance is 2 root 7 centimeters. Got it? So distance is equal to 2 root 7 centimeter. Everything else is in centimeter, right? So this is equal to centimeter. Is it clear, kids? Is this clear? The question and the answer? Any doubt? Completed? Next question. Find the answer. Be quick. Find the answer. Okay, I'll drink some water.
Done, miss.
Over, fine. Your answers in the chat box, please. Those of you, your answers in the chat box. Alright, Sai, shall we? Let's go. Tell me, what do we do?
First, we take the radius of 10 centimeter and the distance from the cross from the
Okay.
center 5 centimeter, and then use the Pythagoras theorem.
Okay, so let's draw a circle first. Draw the center. Okay. So we have to draw a chord. Let's draw a chord. Let it be AB. Find the length of the chord, which is at a distance of 5 centimeter from the center. So from the center, it is at a distance. Perpendicular distance is 5 centimeter. And yes, radius of the circle is 10 centimeter. So from A to B, it measures 10 centimeter. Now what do we do? We can find AC easily. What is the theorem that we can use here?
The theorem,
Yeah, theorem. We can find AC. How will we find AB? Come on. You should say you're on mute. You're mute. Unmuted. Unmuted.
use the Pythagoras theorem.
Pythagoras theorem, we can use it here. And then after that, what do we do? Okay, let's go. We can use Pythagoras theorem. So that is hypotenuse square is equal to base square plus height square. So what is the hypotenuse here? You muted.
10 square.
10 square, very good. 10 square is equal to
5 square plus x square.
5 square plus x square. Okay, let's take AC as x then. Okay, so base is x, right? So x square plus 5 square. Either way is fine. Addition, right? X square plus 5 square. Now,
100 minus 25 equals x square.
okay, so 10 square minus 5 square is equal to x square. So 100 minus 25 is equal to x square. So x is equal to
75
root 75. Very
Or
good. So prime factor is 75.
25 into 3.
Yes. 25 into 3. Very good. 75 is equal to.
5 root
It's equal to 25 into 3. So 25 is 5, right? Root 25 is 5. So 5 root 3. Okay.
yeah.
Got it.
But ma'am, in the
Yes.
question, it's saying to find the entire code, right?
Yes. Yes. So we have to. It's not complete. The answer is not complete. So AB is equal to. This is AC. AC is equal to 5 root 3. AB is equal to. Come on. 2 into 5 root 3. Very good. Which is
10
equal to 10 root 3. Okay. So both of you got the correct answers. Very good. Alright. Okay. So listen, kids, what theorem are we using here? Perpendicular from the center of a circle bisect the chord. The chord. Okay. Bisects the chord. Perpendicular from the center of a circle bisect the chord. Okay. Completed? See? Find the full length of the chord. Because the distance from the center bisects the chord, we multiply half length by 2. Next, look at this. Look at the question, okay? This picture and everything might seem a little complicated, but read it carefully. It's very easy. Okay, read the question, get to the answer.
Uh, can I say it's basically the like a radius into two, right?
Yeah, so this in the chat box, in the chat box, in the chat box. Tickets, actually this figure won't be given to you. Only the question will be given. Okay, this figure will not be there, just the question. So you will have to draw the figure. That's the main part. Okay, this question is actually pretty easy to answer. But constructing the proper figure, there kids might make mistake. Okay, so two circles of radii 5 and 3. So we know that one circle is bigger and the other is smaller, right? Because different radii. The circle with the radii 5, that is radius 5 will be bigger, and the circle with radius 3 will be smaller. Okay, intersect at 2 points. They are intersecting at 1 and 2, 2 points. Okay, and the distance between their centers is 4 centimeter. So suppose this is the center of the bigger circle, this is the center of the smaller circle. They're intersecting at 2 points. Okay, that's where the chord is. The distance between the centers are 4 centimeters. Distance between the centers are 4 centimeters. So this hole is 4 centimeters. Okay. Find the length of the common chord. You have to find the length of the common chord. And we know that their radii are 5 and 3, right? So the length from this point, let this be A, B, O, and P. Okay. AO will be 5 centimeter. And AP will be 3 centimeter. Isn't it? And this is 4 centimeter. Okay. So listen, look at this. Look at this. Over here. Oh, wait. One minute. When I drew, the second circle became a little bit larger. Okay, that's because I didn't take the correct measurement. Okay, when you measure it properly, you will get an exact figure like this. Okay, so this will be the bigger circle and this will be the smaller circle. They are intersecting at 2 points. Okay, and that 2 points, let it be A and B. Okay, A and B. And the distance between the first and second circle, that's how you have to draw. The centers are at a distance of 4 centimeter. That's why the center of the second circle will be inside the first circle. Because the distance between them is just 4 centimeter. If it was too much, like if it was much more than 4, if it was like 8 or something, the center might be outside. But since the distance between them is 4, it lies inside the first circle. Okay? So see the first circle has the radius which is 5 centimeter. Since the distance between them is less than the radius of the first circle, the center of the second circle will lie inside the first circle. Okay. So now connect the two lines. This AB will be the chord, the meeting points. The point where the two circles intersect will become the points of the two ends of the chord. And we know that this is 4 centimeter, this is 5 centimeter, and the length from here, let this be C1 and C2. C2 to A is the radii of the second circle. Second circle, isn't it? Is the radii of the second circle. So it is 3 centimeter. So what will be the length of AB? Come on. It is? Yes, your answer is correct. Come on. 6 centimeter, right? Because perpendicular from the center to a chord bisect the chord. Therefore, AB will be 2 into 3, which is 6. That's it. Is it clear, kids? Any doubts? Okay. Next question. You have to prove this. You have to prove it. Give it a try. Concentric circles. You know the meaning of concentric circles, right? And one more thing, the picture may or might not be given to you. Keep it, if it's like, for a smaller mark question, the picture may be there. But if it's for like a more higher mark question, the picture won't be there. So you have to draw 2 concentric circles and a chord that is passing through both of them. Okay.
Is the line AD passing through the origin or it's like a chord?
It's a chord. Okay. If a line intersects 2 concentric circles with the same center, at center, okay, with center O at A, B, C, and D, prove that AB is equal to C. Okay. With center O, it is not passing through the center. If it was, they would mention it in the question itself. The line is passing through the center. So, does any of you got that? Did any of you, are you able to get anywhere? Are you able to get into anything? You have to prove this AB is equal to CD. This AB is equal to CD. Do you do? Like obviously they're equal, right? But we have to prove it. So I'll give you a clue. If you can see, for example, let's say, okay, you have to draw a line from O to AD. You have to draw a line, a perpendicular from O to AD. Perpendicular from O to AD. Then what happens? Let's say OM.
The line
OM
is bisected.
exactly. OM bisects OM bisects the line AD. Okay, then BM will be equal to CM, right? And AM will be equal to DM, isn't it? So subtract them. See, from this area, from AM subtract BM. From OD subtract from DM subtract CM. That's a clue. Okay, we'll do it, kids. Okay, with me. So first draw OM perpendicular to, draw OM perpendicular to, draw a perpendicular from the center of the circle OM to the line AD. Draw a perpendicular from the center of the circle OM to AD. Okay? So we can see that OM bisects, what happens? OM bisect AD, isn't it? OM bisect AD. and BC, isn't it? OM bisects AD and BC. Therefore, BM is equal to BM is equal to BM is equal to
CM.
CM, and AM is equal to
MD.
DM, isn't it, Sai? Are you able to understand this? Are you with me?
Yes, miss.
Equation number 1 and 2. Now subtract 2 minus 1. 2 minus 1, do 2 minus 1. That is, from 2 you have to subtract 1. Come on, tell me. AM, AM. Come on, kids, tell me. AM minus
minus BM
BM is equal to,
or CM minus DM.
sorry, no, DM minus, see, 2
CM.
minus 1. DM minus,
CM.
the bigger one minus smaller, right? We have to subtract big from small, small from big, isn't it? So which is the bigger line? AM, right? And DM. So from the bigger line, subtract the smaller line. That's why we are doing 2 minus 1, okay? You should know why we are doing 2 minus 1 and not 1 minus 2. Because AM is the bigger.
Are we
Okay?
supposed to do like, because M is common in both of them, where to cut or something like that? I'm not sure.
No, it's just subtract it. What happens? See, from this AM, line AM, subtract BM. What do you get? What is remaining? What's remaining?
AM.
AB, right?
Oh, AB, sorry.
From AM, subtract BM. What is remaining? AB. Similarly, from DM, subtract CM. What is remaining?
AB
What is
equals
remaining?
CD, DC.
Yes. So this is AB equal to CD. That's it. Simple. Okay? Or a little confused over here? Are you guys a little confused over here? It's simple. It's very simple. Draw a perpendicular OM from the center to AD. It bisects the line, right? So we have BM is equal to CM and AM is equal to DM. Now since AM is the bigger line and DM is the bigger line, 2 minus 1. So AM minus BM will be equal to BM minus DM minus CM, isn't it? DM minus CM, which is equal to AB minus, sorry, therefore AB is equal to CD. That's it. From the figure. Simple as it is. Completed? Completed? Over? Next. Okay, just look at this answer one more time. Just go through the proof one more time. Over? Next. Prove that the line of the centers of two intersecting circles subtends the equal angles at the 2 points of intersection. You guys have to do it. Remember how we proved questions in the previous theorems on day 1? Just think about the same logic. If we have triangles, what did we do? Okay? Same method, same ideas, but you have to go through. You have to tinker with it. Okay? Prove the line of centers. Okay, prove that the line of centers of two intersecting circles. Prove that the line of centers of two intersecting circles subtend equal angles. Okay? Line of centers of two intersecting circles subtend equal angles at the 2 points of intersection. See, I'll explain the figure. We have two circles. Okay? The line of centers of two intersecting circles. Okay, so the line of centers of the two intersecting circles. Line that meets two centers of two intersecting circles. So they must be intersecting at 2 points, right? Let it be A and B. Okay? And the line that's connecting them, like, the joining. Okay. P and Q is the line that connects the two centers of the two circles. Subtends equal angles at the point of intersection. So it subtends equal angle at the point of intersection. It intersects at A and B, isn't it? So at this point, we have to prove that they subtend equal angle. So this angle PAQ is equal to PBQ is what we have to prove. Is the question and the figure clear?
So we have to prove that AB is like intersecting like that.
So we have to prove that subtend angles. See, the circle subtends equal angles. It subtend equal angle. That's what we have to prove. Now this line PQ subtend equal angle at the point of intersection. That is at A and B, PQ subtend equal angles. That's what we have to prove. Okay, thus angle subtended by PQ at A and B. That is these two angles, right? Angle at A and angle at B. There are two angles marked here. PAQ and PBQ. We have to prove that these two angles are equal. That's what we have to prove. Okay. So normally in the previous day theorems, when we prove the theorems, what did we do? We'll have two triangles. And what did we do with the two triangles? See, if we can show that the two triangles are corresponding, we can say any angle. If we can Okay, kids, listen. If we can prove that the two triangles are corresponding, then any of the corresponding parts will be equal, right? CPCT. So that's what you got to do. I gave you a lot of clue. So see, kids, in your exams, I won't be there to give you such clues or to explain the question. You have to read the question, understand it, understand the figure, and prove it by yourself. So do it. The chapter is very easy once you understand the concept and once you know how to prove the question. See, every proof has a common pattern. We'll have triangles, we can just prove they are corresponding, and then by CPCT, the parts we need, we show that they are equal. Right? We have a common pattern. But you have to understand the idea, you have to learn the theorems. Okay, you have to learn to use the previous theorem in the upcoming questions. So carry on, continue. Over? All right. So let's go, let's go. Who's gonna prove it? Okay, Aisha, begin.
I'm not sure if this is correct. I didn't know what is give. I didn't know what is what we have to write for given. But I wrote to prove. You have to prove that angle PAQ equals to angle PBQ.
Yes, angle PAQ is equal to
And
angle.
the PA is equal to PB because they're both the radius of the bigger circle.
Yes. So we can write that. Okay, we can write. Let's continue. You can write all those things. See, you can just if you're confused on what to write as given, look, read the question, read the theorem. Okay, prove that.
No, I read the question and I didn't understand what I read. That's why.
Prove that the line of centers of two intersecting circles. So we have two intersecting circles. Write that first. Two intersecting circles with centers P and Q. Okay, that's a given. Two intersecting circles with centers P and Q. Okay, substance. Okay, that's it. That's it. All right now, what you can write as given is two intersecting circles with centers P and Q. Okay. All right. Now we have to prove that angle PAQ is equal to PBQ. For that, we have the two triangles. Okay, let's continue. Aisha?
PA is equal to PB because they are both radius of
Triangles. Which triangles are we comparing?
uh, like both of them.
So we have to write the in triangle. See, how do we start in triangle? We have to write the name of the triangle. We are comparing them, right? In
Yeah. So in
triangle
PAQ,
PAQ and triangle PBQ.
PA is equal to PB
Very good. PA is equal to PB. Reason?
and QA, they're both the radius of the bigger circle.
Okay, radius of bigger circle. Okay, bigger circle. Okay, and then
QA is equal to QB
QA is equal to QB.
because they both are the radius of the smaller circle.
Smaller circle. And
PQ is the common line in
good,
both.
good, very good. PQ is equal to PQ. Common.
Yeah, since we got all the sides, we can like hence prove the equal.
Therefore, by which congruence rule?
Uh, side, and angle. I don't know the order.
Is there any angles over here?
Isn't PAQ an angle? So,
But that's what we have to prove, right?
okay.
Not what
So
is given. See, we use the rule by whatever we have. We have three sides are equal. Then by side congruence rule. Okay? Side congruence rule. Congruence rule. SSS congruence rule. Triangle PAQ congruent to triangle PBQ. Therefore, by TPCT, corresponding parts of congruent triangles, angle PAQ equal to angle PBQ. Is it clear? Side? Look at this. That's how you have to do it. Alright, you have to write this SSS congruency rule. See, if you're confused on how to write the rule, see, look at what we have. Look at what we have. Okay, which sides or which angles did we use to say that it's congruent? We use three sides. So by side property. Not what we have to prove. It's not something that is already given or that is true. Right? It's something that we are proving is true. Use whatever is true and whatever is given or whatever we have as a fact. Okay? Next. Okay, we're getting a little more challenging here, but it's not difficult. If it's not, you can give it a try. Use all the properties. Remember the properties that we learned. You have to prove that the chords are equal. Okay, so first of all, I want you to tell me which theorem we can use here. Like a theorem that one of the theorems that we learned in the last class, we can use to solve this question. If two intersecting chords of a circle make equal angles with the diameter, So we have two intersecting chords AB and CD. Okay, and AB and CD intersect at E, which is also which also intersects the diameter PQ. It is also intersecting with the diameter. Okay, BC and CD. Okay, if two intersecting chords of a circle make equal angles with the diameter, it makes equal angles with the diameter intersecting at point E on the diameter PQ, and it makes two angles here, right? See, read the question. It says that make equal angles with diameter. So there, from that sentence, you should realize where the angles are with the diameter. So this is our these are our chords AB and CD, and the angle they make with the diameter. These are the angles, right? 1, 2. These are the angles they make with the diameter, and it says that they are equal. Clear? So passing through their point of intersection proves that the chords are equal. You have to prove that AB is equal to you have to prove that the chords are equal. Chords, what did we name the chords as? AB and listen, kids. Come on, complete. When I stop, you have to complete. What do we have to prove? What do we have to prove?
AB is equal to CD.
Okay, what's given?
There are two intersecting chords, and like we have to prove if we have to prove if the chords are equal by using the diameter.
We have to prove chords are equal, but something else is given. What's the most important point that is given to us? If two intersecting chords of a circle make equal angle with the diameter, it is said here they make equal angle with the diameter. So what is given? Which are the equal angles here? Sai, come on, answer. Which are the equal angles here?
AEQ and QED.
Good. Sai, come on. Let's take with the L. Let's take the we need to take the triangle. LEO and LEO and LEO and one more time, listen. One more time. I need you to focus here. If the two intersecting chords of a circle, so we have two intersecting chords. They are intersecting at E on the diameter. Make equal angle with the diameter. So this AB make an angle with the diameter. LEO. BC make an angle with the diameter. MEO. And they are equal. That's what's said in the question. Understood? This LEO and MEO are equal. That is given to us. We have to prove AB is equal to CD. Okay? So read the question twice or thrice until everything is perfectly clear. Such questions will come for you, not the exact same one. You will have to understand it, you will have to get the idea, and you will have to answer it by yourself. So read it carefully. See, two intersecting lines, chords, make equal angle with the diameter. So the chord and the diameter. Look at the angle. Look at the angle which is between the chord and the diameter. With the diameter, right? So the angle between the chords and the diameter is LEO and MEO, isn't it? Yeah, saw your video.
Is BA being bisected by the point L?
Yes, of course. We know the theorem, right? OL is a perpendicular from the center. It will bisect AB. OM is a perpendicular from the center. It will bisect bisect CD. But we have to use something else also. We have to use something else. Is that the only theorem that we studied yesterday? Towards the end, what did we study? Name the other theorems that we studied. Someone tell me the other theorems, not naming it. Tell me the other theorem. We studied a theorem related, like, that relates the length of the chord and the distance from the center to the chord. What was it? If the distance from the center to two chords, any two chords, are equal, then the length of the chords will be. See, that's why. If you don't revise, if you don't study, then you won't be able to answer. This is just an application question, right? You will get many different kind of questions just like this in your exam. And you will have to prove it. If you don't know the theorem, you won't be able to what? Prove it. So listen carefully, you have to study this theorem. What's the theorem? See, if the distance from the center to any two chords, two or more chords are equal, then the length of the chords will be equal. Yeah. Equal chords of a circle are equidistant from the center. Equal chords of a circle are equidistant from the center. And the converse also. Chords equidistant from the center are equal in length. Chord C, if you have two circles, if you have one or two circles, let's say this is a circle, and you have two chords. Okay, if the distance from the center to this chord and this chord, if this is 2 centimeter and this is 2 centimeter, then you can say the chords, length of the chords are equal. And the converse also, the vice versa also. See, suppose you have a center and two chords. Okay, if the length of the chord is 4 centimeter and the length of this chord is also 4 centimeter, then its distance from the center will be equal. This A will be equal to this A. Understood? Sai, Aisha, these theorems should be there in your mind, otherwise you won't be able to solve such problems. So you can use equidistant to measure the length, to compare the length of two chords. You can use the distance from the center to the chord to compare the length of the chords. So that's a clue for you guys to solve it. Sai, is it clear? Is what I'm saying clear to you guys? Do you have any doubts? Make sure everything that I say is clear, okay? If you have any doubts, to ask me at the moment itself. Over. Use what is given. You should also know one more thing to prove such questions, the congruency rule. SSS rule, SAS rule, ASA rule, RHS rule. You should know all the rules. Okay, I have a work for you today. After the class, Aisha and Sai, maybe go through your 7th standard textbook or using Google. I want you to learn about congruency. The rules, okay, different rules of how to prove two triangles are congruent. Different rules. to prove two triangles are congruent. All the SS, SSS, ASA, all those RHS, all those rules. I want you guys to go through it. Okay? And make sure to write it down on one side of your notebook. Okay? What is ASS rule, SSS, ASA, RHS, SAS, all those rules. Over? Completed? Hurry up, kids, hurry up. Okay, kids, time up. Come on, Sai, you can begin. Hi, hello.
Just begin with the
You can just begin with the proof. Begin with the proof.
O and E equal to angle O and E because it's 90.
Angle OLE is equal to angle OME because it's equal to 90 degree. Very good. And
Angle L equals to angle ME. So it's already given.
angle LEO is equal to angle MEO given.
OE equals OE. It's common.
Yes. OE is equal to O. Common. Very good.
And
That's
then
it, right? Which rule? Which rule?
A is congruent.
Angle? AAS congruence rule. Very good. AAS. Hello, kids? AAS congruency rule. Using AAS congruency rule, we can say that the two triangles are congruent. Okay, before this, write the name of the two triangles, okay? You should write which triangles you are comparing. In triangle. In triangle LEO and MEO. Okay? Therefore, they are congruent. Now, since they are congruent, what can we say?
Yeah, they are congruent.
They're congruent. So, by CPCT?
By CPCT, OL equals OM, which means AB equals CD.
Very good. OL is equal to AM. Therefore, AB is equal to CD. Because why? Why? Chords equidistant from the center are equal in length. If the distance from center to any two chords are equal, then their lengths are also equal. Okay, using this here. Understood? Okay, note it down. See, simple, right? Once you understand it, it's very easy. So all you gotta do is over here, just that one theorem. If you get that one theorem that okay, if we can prove that the distance OM and OL are equal, then we can prove that AB is equal to CD. Okay, if you know that theorem, okay, to prove OL and OM are equal, we can use the two triangles. If we can prove they are congruent, OL is equal to OM. For that, we have many things given, the two angles and one side, so AAS. See? Over, completed both of you, Aisha, Sai, any doubts here? Completely clear? Okay. Next question. Kind of the reverse of the same. I want you guys to do it by yourself. Converse of the same. So what's given will be different here. Okay, the converse will be given to you. Do it.
Done, Miss.
Over? Okay. So Aisha, come on, let's go. So let's go.
No, I'm not done at all. Like, I'm not sure what to do. I'm not done.
It's all right. It's all right. Just I need you to do this. You have to. Compare with the previous question. Take the converse. See, look at the question and tell me what's given.
There are two equal chords and they both are intersecting each other.
Within the circle. Two equal chords and they are intersecting each other within the circle. Okay, so two equal chords. So AB is equal to?
AB is equal to CD.
That's given.
And we have to prove that they both make equal angles with the chord.
Point of. Come on. The line joining the point of intersection to the center. Point of the line. This line, right? Joining the point of intersection to the center. This line. XO. The angle these chords make with XO is equal. That means we have to prove these angles are equal. Okay, that is angle. Come on, tell me the name of the angle.
XMO.
XMO. That's 90 degree, right? What's the name of our angle? OMX is 90 degree. That's a line from center to the chord, right? Perpendicular one. Is that our angle?
MXN.
MXN. That is this whole angle. Do we have to take that whole angle? Then which is the other equal one? What's the see? Line joining the point of intersection to the center. Which is the line joining the point of intersection to the center?
X.
XO, right? XO is the line joining the point of intersection to the end center. Makes equal angle with the chords. Which is the angle? Which are those angles? It makes equal angle with the chords. See this angle and this angle, right? Those are what we have to prove. They are equal is what we have to prove. So what's the name of those angles?
OXA and OXB.
OX what? Can you repeat it?
OXA and OXB.
Take it to M, okay? Because we need to use the triangles, right? So just take it to M. OXM and OX.
N.
This is what we have to prove. Okay? This is what we have to prove. And AB is equal to CD is given. So come on, let's go.
OX is a common line.
OX is common. OX is equal to OX.
OM is equal to ON because they're both bisecting the chords.
That's the reason. OM is equal to ON, but is that the reason? If they are bisecting the chords, then CN should be equal to DN and AM should be equal to BM, right? Not the lines, but they are equal. Another different reason. Just in the previous theorem, what did we use?
They're equal to 90 degree.
They are equal to 90 degree. It makes angle 90 degree. That is one that we have to use here. Angle O MX is equal to angle O NX, which is equal to 90 degree. But the reason why OM is equal to N, tell me. I'll give you a clue. AB is equal to CD is what we have to use here. The chords are equal, therefore, what's the theorem that we used in the previous question?
Because the angles are equal, the chords are also equal.
Good, like okay, that's what we proved. But here in this theorem, which previous theorem did we use? In this question, we used the previous theorem. Now we use a theorem that we studied yesterday. Which one was it?
Like both the chords are like equidistant from the center, so
Exactly. Chords equidistant from the center are equal, right? Chords equidistant from the center are equal. And its converse is also true. We proved it yesterday. What's the converse? What's the converse? Come on.
The converse.
Chords equidistant from the center are equal length. Now converse. If the chords are equal in length,
The center is the center
distance from the center
is equal.
That's what we have to use here. See, it's given that AB and CD are equal, right?
Yeah.
Then the distance from the center will be equal. That is, what is the distance from the center? OM and ON, isn't it?
Yeah.
OM and ON are equal because AB and CD are equal. AB and CD are equal, therefore the distance from the center to these equal chords are equal. OM is equal to ON. Okay? Okay, so we have RHS rule. RHS rule, right? One side, 190 degree and another angle. We have two angles in which one angle is, not two angles. Okay. We have two sides and a 90-degree angle. Two sides and a 90-degree angle. Two sides and a 90-degree angle. Therefore, using RHS rule, we can say the triangles are congruent. Okay, complete it. Okay, tell me then. Then what do we do? Therefore, triangle OMX congruent to ONX. Therefore, continue, Aisha.
The angles OMX is equal to
Is that what we need to prove? OMX and ONX?
no OXM.
OXM is equal to OXN. Good. Okay. That's it. Completed. Sai, did you get it correctly? The complete answer? Okay. Write it down, completed. Very good, Sai, very good. Over? Okay. Alright. So, kids, any doubts? Just go through all the questions that we did today. I want you guys to learn all the questions right now. From the beginning. I want you to learn it. Not just going through it. Write all the questions and answer one more time and learn them. Use the time to study. Okay? Especially from the fourth question. From the fourth one onwards, mainly. Learn, okay? Don't just go through it. Learn. And remember, kids, we didn't discuss yesterday's like that day one answer key, right? Because we were out of time and I wanted you guys to remind me of it, so let's discuss it now. Is the screen visible? Okay. Revise first. Revise all the questions. Otherwise, it will go out of your mind. Okay, revise all the questions that we did today. First, go through it. Learn. Okay. Any doubts? Any doubts in all those questions? Any part, any place that's bothering you guys? Okay, in the theorems that we solved on day one session, do you have any doubts in that? Any theorems, any proofs Anywhere? Okay. So look at the questions. Equal chords of a circle subtend equal angles at the equal chords of a circle subtend equal angles at the center. If the angles subtended by the chords of a circle at the center are equal, then the chords are equal. See, angles subtended by chords of a circle at the center are equal, then the chords are equal. Okay. So remember, we have all these theorems. You have to keep all this in your mind because you will have to use this in questions. You'll be given equal chords. Then you will have to prove something. And you might have to use those angles and you have to use this theorem. Okay, these are the angles subtended by the chord at the center. Therefore, they are equal by a known theorem. You might have to use this to prove anything. Okay, so this should be there in your mind. Perpendicular from the center of a circle to a chord, bisect the chord. A line drawn from the center of a circle to bisect a chord is perpendicular to the chord. See, vice versa. As for everything, the converse is also true. For all the theorems that we studied till now, the converse is also true. So compare and study. There is one and only one circle passing through dash given known collinear point. See, there is one and only one circle passing through three given known collinear points. See, collinear points means what? What is the meaning of collinear points? Collinear points. What is the meaning of collinear points? Three or more points on a single line is what we call as collinear. Three or more points on a single line is what we call as collinear. Non-collinear means they're not on a single line. Okay. In a circle with radius 10, how far is the chord of length 16 centimeter from the center? In a circle with radius 10 centimeters, so we have a circle with radius 10 centimeter. How far is the chord of length 16 centimeter from the center? So we have a chord of length 16 centimeter and the center. Okay. How far is the chord of length 16 centimeter? So what is the radius? You have to find the length, the distance, this distance. For that, what is given? Radius is given as 10 centimeter. Okay. And the length of the chord is 16 centimeter. You have to find this distance, height, h. You know how to do it, right? What do we do? Pythagoras theorem, isn't it? Okay, first we have to take the half of the chord, that is 8. So h square is equal to 10 square minus 8 square. H square is equal to 100 minus 64, which is equal to 36. So h is equal to root 36, which is equal to 6. That's it. Okay? Two chords AB and CD are equidistant from the center. If AB is equal to 12 centimeter, what is the length of CD? Two chords AB and CD are equidistant from the center. So we have a circle and a center, and we have two chords AB and CD. AB, CD. And their distance are equal. Okay, their distance are equal. If this is 6 and okay, two chords AB is equidistant from the center. This is x, this is also x. If AB is equal to 12 centimeter, what is the length of CD? What is it? Come on, Aisha, Sai. Don't just me. It's a two-way thing. Unmute and say, come on, come on.
12 centimeter. They both
By using which theorem?
the two chords are equidistant from the center if they have like the same distance. I don't know how to say.
Same. Like you have to learn to say it because you have to write it in the answer. You have to learn the theorem. Pretty simple. The idea is pretty simple. See, two chords, two or more chords. It just doesn't have to be two chords exactly. Two or more chords. Equidistant from the center. If the chords are equal in length, then they are equidistant from the center. If the chords are equal in length, then they are equidistant from the center. If two chords are equidistant from the center, then they are equal in length. If two or more chords are equidistant from the center, then they are equal in length. Chords equidistant from the center are equal in length. Equal chords are equidistant from the center. That's it. Equal chords are equidistant from the center. Chords equidistant from the center are equal. Understood? A chord of length 40 cm is at a distance of 24 cm from the center. Find the radius of the circle. So a chord of length 14 cm. So we have a circle. A chord of length 14 cm. 14 cm. At a distance of 24 cm from the center. So from the center it is 24 cm distance. Okay, my drawing is not appropriate, proportional to the question. Just a rough sketch, okay? Find the radius of the circle. You have to find the radius. You know what to do, right? This will be 7. Yes, Pythagoras theorem, exactly. Hypotenuse square is equal to 7 square plus 24 square. Okay, and solving this, you will have that. It will be root of 625, which is equal to 25. Okay? 25 centimeters. If the distance between two parallel equal chords of length 8 centimeter in a circle of radius 5 centimeter is d, find the value of d. If the distance between two parallel equal chords of length 8 centimeter in a circle. So we have a circle. Distance between two parallel equal chords. So we have two parallel equal chords of length 8 centimeter. 8 centimeter. In a circle of radius. So we have a circle of radius 5 centimeter. Okay. So you have to find the distance between the two. You have to find the distance between these two parallel lines. So this is also 5. So you can find this distance, right? They are equidistant, isn't it? The distance from this point to center and this point to center are equal because the chords are equal. Then they are equidistant. The chords are equal, therefore their distances are also equal. If this is x, this will also be x, isn't it? Equal chords are equidistant. We can find this x using Pythagoras theorem. This will be 4. Okay. Pythagoras theorem, x will be 3. X is going to be 3 using Pythagoras theorem. So the total distance from, suppose this is O and this is P. OP is equal to x plus x, that is 6 centimeter. Is it clear? Sai, Aisha, if you want me to explain more, do tell me. Sai, are you here? Okay. Aisha, Sai, is this clear? Using the equidistant property, we are using the equidistant theorem. Equal chords, therefore their distance will be equal. We have to find the complete D. D is equal to x plus x. Okay. So using this triangle, we can use Pythagoras theorem and find x, which is 3. You know triplets, Pythagorean triplets, 4, 5, 3, 3, 4, 5, right? So x is equal to 3. So D is equal to x plus x, which is equal to 3 plus 3, which is equal to 6. Okay? And finally, in a circle, a chord is 10 centimeter long and the radius is 13 centimeter. What is the distance of the chord from the center? In a circle, a chord is 10 centimeter long and the radius is 30. 10 centimeter and the radius is 30. You have to find the distance. Pythagoras theorem. Just use Pythagoras theorem here. Half of 10 is 5. 5, 13, and 12. 5, 13, and 12 are also Pythagorean triplets. Okay. You know how to find the triplets, right? Okay. Is it clear? All the questions? Do you know where you made mistakes yesterday? Yeah. So make sure, get this question answer key, okay? Get the answer key. You can get the answer key from your class teacher. You can just ask her to give the answer key of day 1 circles chapter. Okay, she will give it to you and write the question, find the answer by yourself again. That's how you study. Practice the workout questions. After today's class, you have to practice the workout session questions. Practice the theorem and proof. You have to write and practice. That is the only way to study. Write and study. Write and study. The proof first, write by looking. Okay? Then write by without looking. Okay, if you're not able to get it without looking, if you're not able to complete it, then write once again. That's how you will have to study. Okay, by the time, okay, next class it will be day 2. Before that, you have to be thorough with all the theorems, all the questions that we discussed till now. By then, okay. Sai, Aisha, got it. Because you are very smart. The only thing is you have to practice more. You have to study a little more. You have to put in some more, a little more effort. Got it? You need to practice. You need to write and study. Okay. Anything else, kids? Anything else that you want me to help you with? Any queries? Everything clear? Perfectly clear? Okay. Just go through it again. From the day when, from the starting itself, from the starting of the chapter. You're able to understand everything, right? Do tell me if there is any such difficulty.
Done.
Okay, then I guess it's time for us to say goodnight and goodbye. Okay, kid? So, shall we wind up then?
Yes.
Everything all right? Okay, so good night, yeah, Chacha, and bye bye, kids. Make sure, remember, okay, one more thing, the congruence property, rules, congruency rules. Do not forget, use Google or your previous year's textbooks, like 8th and 7th textbooks, or just using Google, study the congruency rules, okay? Congruency, all the congruency rules and theorem proofs. Congruency rules and theorem proofs, okay? So bye bye, kids. Good night. See ya.
Bye, Miss.
See ya.